Okay, so now we're going to continue on our process of trying to build these confidence intervals by focusing on what's called the critical value. Now, before we get into that, let's talk about some facts from section 6.4. I call these old news. So these are going to be ideas about the sampling distribution of of P hat. Uh-oh, got some lag. There we go. Okay, and again, from last chapter. So first of all, the standard deviation was this formula, okay? Again, that's just the formula we used. We're going to use a similar formula like that in this section. Number two, when the large counts condition is met, you can assume you're approximately normal. Important as well. Number three, according to this 68, 95, 99.7 rule, which I think was actually from section 5.6, P hat will be within 2 standard deviations of P in about 95% of all samples. Remember that the 68% was plus or minus 1 standard deviation. The 95% was plus or minus 2 standard deviations. And 99.3% was plus or minus 3 standard deviations. So again, we're going to be focusing on the 2 standard deviations, which is 95%. So again, therefore, in about 95% of all samples, P will be within 2 standard deviations of P hat. So again, that's what that would mean if we're doing a 95% confidence interval. Kind of fun stuff, which is the most common one. Okay, so note that when we build the confidence interval, this is how we're going to do it, right? We're going to have our point estimate, and then we're going to add and subtract the margin of error. So what are we going to use for the point estimate? What are we going to use for the margin of error? Well, we'll get into that later. Right now, we got to talk about this idea called a critical value, which is our Z star. Very similar to our Z that we found in the stats app beforehand. So Z star is going to be this multiplier that makes the interval wide enough to have the stated capture rate. So to match our confidence level, right? The stated capture rate is the confidence level. So your Z star is going to be very, very, very much related to the confidence level. And we'll talk about it in the example ahead. But we have to make sure we know how to find this Z star value. Very important. Okay, so what's the Z? Find the critical value Z star for a 95% confidence interval. Assume the large counts condition is met. So if this large counts condition is met, this situation is going to be approximately normal. And we can use our stats applet and a normal distribution to find the Z based off of that confidence level. So I want you to think about this, right? Here's our normal distribution, right? 95% of all the data is somewhere in here. That's 95%, right? So that is 95% or 0.95. So that means we have 2 tails here and here. Now, these 2 tails will be identical, okay? And they're going to add up to what's left over. Well, 1 minus 0.95 is 0.05. That's the sum of both tails. This is, I'm sorry. So we'll make this better. So this represents the right and left tail, or the left tail and right tail. However, if you recall finding Z values, the only way to do that in our stats applet is to use the left tail area. I only want the left tail. Well, if they're symmetrical, we can take that 0.05 and divide by 2, and that'll be 0.025. And this is our left tail area. That's what this is. This area right there is 0.025. So now, when we use our stats applet, we are going to be able to find a Z value from an area. That's where you have to take the top drop-down box and switch it, right? So remember that. And then what's going to happen is you're going to get your negative Z star value. We want the positive Z star value. So you're just going to make it positive. It's the same number because it's symmetrical. It's just going to be positive. And that's what we're going to do to find this Z star value. That's it. Okay. All right, cool. So what you need to do in this problem is when you get the confidence level, You need to take 1 minus that confidence level and then divide it by 2. That'll get you your left tail area. So again, this was the explanation. If I was doing this problem, I would do 1 minus 0.95 divided by 2. That's 0.025. You can think of this as your probability value, or that's the area, and it's the left tail area. Okay? So now I'm going to go away from this for a second. And when I go away from this, I'm going to go to the probability stats applet. And I'm going to click on statistical applets, probability, normal distribution. Again, this is the operation. We are not calculating the area. We already know the area. The area is 0.025. We want to find the z value. Our mean and standard deviation is always 0 and 1. We're going to plot the distribution, and I want to calculate the value for a left tail area of 0.025. There is going to be your negative z star value. Your negative z star value is negative 1.96. So the z star value we need in this problem is positive 1.96. And again, recall that we talked about a 95% confidence interval is roughly within plus or minus 2 standard deviations. On the standard normal distribution, that would be positive and negative 2 because your standard deviation is 1. Well, look what our z-star value is, 1.96, which is very, very close to 2. So I hope that that connection makes sense if you're thinking about this cerebrally. Okay. So again, we got to make sure we find these z-star values. And the biggest thing is don't forget to change your operation to calculate a value from a left tail area. All right, great. So that's objective 2. We're going to use this in objective 3.